name is Josh McDaniel. I work with the Wildland Fire Lessons Learned Center. I work with them on editing and writing for one of their websites, Advances in Fire Practice, which you'll hear a little bit about in upcoming minutes. And I'll be introducing the speaker today and then moderating the question and answer session after the presentation. But first I want to make a quick notes and announcements. First, I'd just like to point out that the that the webinar is co-sponsored by 3 different organizations: the Wildland Fire Lessons Learned Center, the International Association of Wildland Fire, and the Joint Fire Science Program. I've put some links up here to direct you to some of their websites and really encourage you to go there and check out some of the growing amount of resources that all 3 of these organizations are starting to put together, especially in relation to wildland fire science. Next, I want to tell you a little bit about the webinar series. We're changing the format a bit, and we're going to start having more webinars. We're going to be shifting into 2 parallel topical series. So the first is, and this is the first in one of those series, in what we're calling the tool shed, looking at different tools that are available in relation to wildland fire, and specifically air quality, smoke management, fuels, fire effects, that sort of thing. And then also a social science topical series leading up to the Human Dimensions Conference, which the International Association of Wildland Fire is sponsoring later next spring. And the next webinar in the series, Ivan Pupoletti of the Rocky Mountain Research Station is going to be giving a presentation on risk management and human performance. That's scheduled for January 10th. And we have a few others that are in the works, but we haven't quite got them finalized yet, so check back with us on, and the best place to find out about them is on the Advances in Fire Practice webpage, and I've put the link up there, and you can register for the webinars there and see which ones are upcoming right there. Okay, so on to today's webinar. I'll introduce the speaker in a second, but I just want to let you know how questions work. So what we'll do is, if you have a question, you can type it in the box in your control panel, and depending on what type of computer you're on, it should say questions or chat, and then you can type it in there, and then we'll get to those at the end. But feel free to type the questions in as we're going along so we can have them in the queue and get them organized. All right, and also one quick is that webinar is recorded, and we store those for about a week on the Advances in Fire Practice webpage using some of the software provided by the webinar company. And then they're eventually archived on the Frames website, and we provide links to that on the Advances in Fire Practice webpage as well. So if you want to pass on the link to someone you think might be interested, feel free to grab that. And at the end of the webinar, I'll put this link, the link for the recording up, or where you can find the recording. And it's usually available about 30-45 minutes after the webinar. Okay. Oh, so real quick, before I introduce Miriam Rogers, let's find out how many people, who we have in the audience here. This is a big audience. I'm showing we have 180 people here, 280 registered, so this could even grow even higher. This might be one of the biggest webinars we've had yet. But we have a couple poll questions, so you can just go ahead and click and answer and we'll just find out a little bit about the audience here. So go ahead and, didn't mean to do that. Okay, so there's the first question is, who's your employer? Just to kind of figure out where most people are coming from. Alright, so most everyone has voted now, so I'll put that up. So it looks like mostly we got Federal Land Management Agencies representative with another large contingent from state and local, and then smaller representatives from some of the different other categories. All right, so let's see. Let's try. Next question. So what is your connection to wildland fire? right, so it looks like we have a large contingent of fire practitioners here. That's good, because I think this presentation should be right down your alley. Let me share that with you. So 66% fire managers are firefighters, and then another large chunk of land managers. Okay, and one last question, and then we'll get to Miriam. And this is, how often do you directly deal with air quality or smoke management issues in your job? Okay. So this is an audience that this topic is near and dear to their hearts, I'm guessing, with 55% regularly and 42% occasionally dealing with air quality and smoke management. So with that, I'll go ahead and start introducing Miriam Rogers so she can let us know about some of this cool stuff that she's been working on. Miriam is a research meteorologist with the Air Fire team out of the Pacific Northwest Research Station, and she specializes in fire weather meteorology and smoke dispersion modeling. Her work is focused on dry lightning outbreaks and generating predicted fuel moistures and fire weather indices using output from meteorological models. Her work's also been instrumental in the development and evaluation of the Blue Sky smoke modeling framework, which incorporates several models into a single tool for managing the impacts of smoke. She participates in field studies to collect meteorological and air quality data and provides expert smoke modeling analysis on major wildfire incidents. So with that, I will hand it over to Miriam, and welcome, Miriam. We'll let you take over now.
Thank you. Okay, welcome everyone, and thanks for your interest. I want to talk to you today a little bit about some Blue Sky enabled tools and the WFDS Air Quality Portal. And this is a website that we have developed to try and get some of the Blue Sky and Blue Sky enabled tools into the wildland fire decision support system. So these are going to be both tools that eventually will be available either within WFDS or as a standalone, so you can use them without having to go into WFDS. Anyway, let me get this into slideshow mode and we can get started. The first question, of course, is why do we care about smoke at all? And for most of you that deal with smoke, you know that we've got some very good reasons. There's nuisance smoke that just impacts people if they're outside playing ball games or doing whatever. There's also the visibility issues. You've got smoke on roads that reduces visibility, and that causes problems. There's very definitely health effects. We've seen increased hospitalizations and increased mortality with very large smoke events. And also there's concerns about air quality standards. There is discussion, and it's likely that air quality standards are going to be tightened, and so areas that are now not non-attainment areas could well become non-attainment areas, not because of any change in the amount of burning, but just because the standards have changed. So we need to be very aware of smoke and how to mitigate it. In order to get some information on what our smoke impacts are going to be, we have to answer a whole series of questions. And this becomes a logical progression. So for example, we need to know what's the weather going to be, which direction is the wind going to be blowing, is it going to be stable, is it going to be unstable. We need to have information on the fire. Where is that fire located, how big is it? We need to know what fuels are on the ground. We need to know how much of those fuels are actually going to be consumed before we will be able to estimate emissions. We need to know what time is the fire burning. If it's a prescribed burn, what time is the burn planned for? If it's a wildfire, we're going to expect that most of the active burning is going to happen in the middle of the day. We need to be able to estimate the emissions. We need to get estimates on how high the smoke is going to go, because that's going to tell us whether our impacts are going to be local or maybe a little bit longer range. And then and only then are we going to be able to answer the question of what the smoke impacts are going to be. So because we have to go through all of these steps, we set up the Blue Sky framework to follow this logical progression. And these become all of the modeling steps within the framework. So we have the meteorological model, we have fire information, we have fuels information, fuel models, we've got consumption models, you know, again, the time rate, when is the stuff burning, emissions models, plume rise, and so on. And if we want to look at the Blue Sky framework, these are the models that we have incorporated within the framework. And we refer to Blue Sky as a framework, I have to make this clear, because it's not a model, it's a framework that enables several different models to be able to work together to get you from the meteorology to smoke dispersion. And Blue Sky enables many different models to be used at each step of the modeling pathway. So for example, with the meteorological models, we can use either the WRF or the MM5 or GFS or NAM. With fire information, we can use SmartFire, which is a combination of the satellite detects plus the ICS 209s. We can put prescribed burns into the system. Fuel models, we've got several different FCCS, NFDRS, for example, and all the way down the line you can see the different models that we have. And on this slide, the bold models are the ones that are currently implemented. The slide may be a little bit out of date, and some of the unbolded ones may be implemented now. But you can get an idea of what we have available within the framework. And it's important to realize also that it's not, doesn't just have to be a linear starting from the upper left corner and going down to the lower right corner. There's useful information that we can get out of each step of the pathway, and you don't necessarily have to go all the way through in order to get information. So for example, you can get total consumption or you can get total emissions without having to go all the way through. So lots of information we can get here. The thing about the models is the biggest question is how much confidence do you have in the model output and how do you interpret what the models are telling you. So in order to be able to answer those questions, we really need to have a reasonable understanding of what the models are doing and what inputs do they require. So depending on which models we're using, we need to have some basic information really for all the models. So obviously we need to know where is the fire, how big is the fire, how much are we expecting the fire to grow. We have to have some estimate of the fuel loadings and fuel moistures, and depending on the models there could be other inputs that are required. But one thing to realize is that just because you can enter a variable, just because a model allows you to enter a variable doesn't mean that it will actually use it. And so that can cause a little bit of confusion sometimes. But the better understanding you have of the model you're using and what the inputs are, then you'll be able to better assess the output and whether or not you have confidence in it. And the basic thing to remember here is that the models aren't going to do your job for you. The models are there to help inform your decision, but you can't just take the answer and run with it. So the models will help inform your decisions, but they can't make your decisions. And I just want to show you one example of how the inputs can vary depending on which system you're using. So this is what I'm showing you here are total fuel loadings from the tripod fire, which was in Washington State several years ago. And this is using several different systems. We've got the NFDRS, we've got the Hardy fuel classification, the FCCS, and there's also the FCCS landfire crosswalk. And the images across the top are at a resolution of 1 kilometer, and the images across the bottom are at a 30-meter resolution. And you can see there's huge differences between which fuel models you decide to use for your consumption and emissions model. So if you're using NFDRS, you'd expect that you are going to get lower emissions than if you were using FCCS landfire because the fuel loadings are much lower. And it's hard, obviously, unless you're familiar with the area, to really know which one of these is correct. And I'm putting air quotes around correct because really they're just estimates anyway. And in this case, it turns out that the best estimate is the one in the middle on the bottom, which was done by the people on the Okanagan-Wenatchee National Forest, and that's not surprising. They're local, they know the forest, they know the fuels, and that works out best. But you don't always know which one of these is going to be the best estimate for the fuels on the ground. So the more local knowledge you have, obviously the better off you are. And I want to take this idea and generalize it to the continental U.S. This is looking now just at 100-hour fuel loadings, and I'm comparing two different fuel models, the FCCS and the NFDRS, and this is just showing the difference between the difference in fuel loadings, difference in 100-hour fuel loadings between the FCCS and NFDRS. So where you see the blue colors, the NFDRS fuel loadings, 100-hour fuel loadings are higher than the FCCS, and where you see the red color is the FCCS fuel loadings are higher than the NFDRS. So for example, if you look along the northwest coast of the U.S., you'll see a lot of blue, which indicates that the FCCS fuel loadings are less for the 100-hour fuels than the NFDRS. And it's not just the fuel loadings, it also matters which models you're using. You can get different results. So now we're just going to focus on FCCS fuel loadings. We're going to look at total consumption, and we're going to compare two models. We're comparing consume, and we're comparing that with FEPS, and taking the total consumption from consume, sorry, I'm saying this backwards, taking the total consumption from FEPS and subtracting that from consume, and what you're seeing is for most of the country, consume is actually consuming more than FEPS. So the more you know about your models and how they work, the better you'll be able to understand the output and utilize that. So just to reiterate, when we're interpreting the model output, we really need to have a good understanding of what is going into the models, what the models are using. You need to understand some basics about the models. So what assumptions are they making, what shortcuts are they taking, and so on. And also it's good to understand the resolution of the model. Can it even see some important terrain features? And I've got some output here of the fires in the southwest, Arizona, New Mexico from last summer to illustrate that. These are some customized model runs we did at about a 12-kilometer resolution, and you can see that reflected in the pixels for the output. But you can see that there's very many drainages that are much narrower than what the model can even see. And in particular, if you look up in the upper right-hand corner by the Las Conchas fire and Pacheco, especially with the Pacheco, there were some real concerns about drainage flow at night that would bring smoke into Santa Fe, and these models just didn't have the resolution to pick that up. And so you have to have some real knowledge of your local area in order to help you interpret what you're seeing here, because this model isn't going to be able to tell you anything about drainage flow. Another tool to help you interpret your model results, obviously, is if you have observations to go along with and compare at the same time. And we're still, I'll show a few slides here from the Southwest because we did a lot of work there last summer, but this is showing some model output off of the Wallow fire and some others, and in the lower right-hand corner I have a time series, a 24-hour time series of PM 2.5 concentrations for the town of Springerville. And you won't always have observations to compare, but in some cases you will. And in this case, both the states of New Mexico and Arizona have permanent PM 2.5 monitors, and that information is available online, so you can actually compare your model output if you're on a wildfire event, for example, with the monitors. And we also had several portable monitors put out too, so we were able to fill in between the permanent stations and really get a good dense network of observations. The other thing I want to point out is that when you're looking at model output, don't disregard what I'm calling close misses in space and time. So in this case, this observation data is from Springerville, and that's the little push pin. I don't think, oh look, that does work. Okay, so that's the little push pin right there north of the Wallow fire. And while this doesn't match the observation very well because the observed value was much higher than the predicted value, this is just the last hour I'm looking at, you can see that there are higher concentrations that are very close. So you may miss by an hour or you may miss by a pixel, but you should still bear in mind that it's likely that there could be smoke impacts even though that exact point didn't get hit. So another way to help you interpret your model output and assess your model output is to do multiple model runs and vary the inputs. So you can change things like fuel loadings or fuel moistures, you can change the area burned, and then compare the outputs and see, are you seeing big changes? If you make little changes in the inputs and you see big changes in the outputs, you might be a little bit skeptical about how well the model is performing. But if you're seeing expected changes, then you have more confidence in your model output. And to show you an example of that, we did, as I mentioned, several customized runs for the Southwest last summer, and we used different fire growths for each day. So I'm just going to show you an example of what we considered to be a moderate growth. And on this day, I believe we were modeling, we didn't have every single fire in the system, but we had the Wallow, we had some fires down here, the Horseshoe, and some other, you can see the Donaldson here and the track fire up here. So for all of these fires, we assumed what we were calling a moderate growth for that day. And then we also did a high or extreme growth, and that's the output for the large growth. And I'll flip back and forth a little bit so you can see what we're seeing is there's not a whole lot of difference in the footprint on the ground as to where the smoke impacts are, but we're seeing higher concentrations with the larger growth, which is kind of what we would expect. So that's another way you can try and get a handle on whether your model output is believable. Okay, now I'm going to pivot to the actual tools. We have developed some of these tools for use, as I said, within the Wildland Fire Decision Support System. And the website is right here, http://firesmoke.us. And I'm just going to do a couple of screenshots here with the PowerPoint, and then I want to wrap this up and actually go into the website and do a couple of quick demos. But what you'll see here when you go in is an opportunity to set your location. You can either click on the map to set your location, or you can enter latitude and longitude, and then you can get to any of these tools and run models based on the fire location that you've provided. And it's not real obvious, but I just want to point out there's a little help link here. that will take you to help pages for each specific tool. And there's also a contact, so if you don't find your question answered, there's an email address, and you can just click and send an email, and we should get back to you certainly within the day, hopefully, to answer your questions. So the goal of developing this website was essentially to just provide a one-stop shopping place so that you would have one place where you could access all of these tools. The idea was also to be able to get information out of WFDS, to drill down into these tools, and also to avoid having to do multiple inputs, you know, constantly re-entering your fire location, for example. So we're continuing to better integrate with WFDS. Right now, the only information that's coming out is the location of the fire, but we'll have more information coming soon. And then, as I said, the idea was also to provide help instructions and things like that to make the tools easier to understand. And we've got 8 tools currently on this website. There's a smoke guidance point forecast, which uses the GFS to give you a point forecast for your fire location. So you're going to get, right now it's a text-based forecast out to 7 days, every 3 hours, of mixing height, wind speeds, ventilation rate, Haynes index, and the like. We have smoke guidance maps. These are either national, as you see here, or we've also got regional maps, and these give you graphical displays of a lot of those same variables: mixing height, winds, ventilation index, and also PM 2.5 if there are fires in the area. We have wind roses, climatological wind roses from ROS stations, and these are just giving you the essentially the climatological average winds for that ROS site. We've got current air quality monitoring data. This is the Air Now site, and this is going to give you information on basically what's the air quality now and forecast for the rest of today. And this may or may not include smoke, depending on whether or not there are fires burning in the area. But for example, if you're using this to plan a prescribed burn, you might want to take a look and see if there's other non-PM 2.5 that's impacting the airshed, and that may help you decide to go ahead with your burn or maybe to postpone it if the air quality isn't good already before you even strike the match. We've got climatological ventilation and mixing height statistics. This could be a whole webinar on its own, so I'm not going to spend too much time on this, but this is just a 30-year climatology at a 5-kilometer resolution over the continental U.S., Alaska, and Canada, giving, again, mixing heights, winds, and ventilation index. Then we've got probabilistic smoke impacts based on climatology. This is also known as AQIPT, and this one isn't quite accessible from the WFDS AQ page yet, but this is the same sort of a planning tool that, given, for example, whether or not it's an El Nino or a La Nina year and what time of year it is, what are your expected smoke impacts. We have custom while you wait trajectories, and it's called while you wait because you, as I'll show when I demo it here in a couple minutes, you actually do have to wait for a couple of minutes because the model is running on the server after you put the information in. And there's also custom while you wait fuels, fire consumption, and smoke impact modeling, otherwise known as the playground, the Blue Sky Playground, which is a lot easier to say. But this is also, as you step through and run each model, it's running back on the server, so it'll take just a couple of seconds for the models to complete before you see the results. So each tool is briefly explained on the website. As I said, there's help pages, and you should be able to easily find what you're looking for there. And I just want to point out the tools are provided by the Air Fire team, Desert Research Institute, some of the other FCAMs, and also Sonoma Tech. And this is just a quick screenshot of the Blue Sky Playground. I'll go into that in more detail in a minute, but I just wanted to point that out and to mention that we are currently undertaking a redevelopment of the playground. Right now it's not really designed for prescribed burn planning, and so we're revamping it to better handle broadcast burns and allow you to break that up into sections or to do pile burns. There'll be automated reports and the like. So we're hoping to roll that out around the March timeframe. So going forward for next year, we want to make sure that the smoke information is robust, it's fully available on a 24/7 basis. We're in the process of developing new training materials and help resources and trying to develop a kind of a cadre of experts that can help other people with questions. We're planning to develop a simple text-based smoke report to provide some guidance for non-experts. And as I said, we're going to be integrating this more fully into WFDS. And I want to talk briefly about this automated smoke report that we're talking about. It's going to have a regional context. It will give you a short-term, like the rest of today and tonight output, along with a longer range 2 to 5 day output out to 6+ days based on climatology. And it could be something as simple as a little chart like this with a few words. It should be easily understandable by a novice user, and there can be guidance. For example, if it looks like you are going to have maybe short-term local smoke impacts, it might suggest that you go talk to somebody that's more expert in smoke dispersion modeling or smoke management. But in this example, you've got a small fire that's expected to die down, but you've got larger fires regionally, and so the current and short-term and nearby conditions are not terribly concerning, but on a regional basis and for longer term, we may have some smoke issues because of those larger fires. And I just wanted to provide a list of where you can find some of these things. Not all of these I've talked about, and this isn't a complete list, but the WFDS AQ portal that I'm going to show you next is at firesmoke.us. You can also get some model output for the continental U.S. at GetBlueSkyorg. Unfortunately, this requires a login and a password, and I hate that because even though I've got one, I always forget it. But it's all you need to do is request a login and you'll get it. And then for the Pacific Northwest, we've got some regional model output at today.airfire.org/PNW4. And then the National Weather Service and NOAA have some smoke products too. There's air quality smoke dispersion at the airquality.weather.gov, and there is also, you can access the high split model at ready.arl.noaa.gov/highsplit, and this PowerPoint will be made available, so you'll be able to copy these down. So that was the end of the PowerPoint. I just want to acknowledge that we've had funding from the Forest Service, Fire and Aviation Management, WFDS. We've gotten a lot of support from JFSP in development of these tools, NASA, National Fire Plan, EPA. We've got some ARA funding and others. And if you've got questions, you can always contact me, or you can also contact Sim Larkin. So I just want to real quick go through a couple of these tools. Oops, that's not the one. Here we go. So here we are at our firesmoke.us. Here's the little help button that I was trying to show you, and unfortunately I'm on the Forest Service network, so things don't happen quickly. But there's all of the tools have help pages, and there's also an output matrix of the available products, and this is kind of a useful little help page if it ever comes up. Okay. Slowly. There we go. This gives you a little summary of what you can get from each tool in terms of which variables and whether you're looking at climatological data, current conditions, or forecasts. So if you just want a quick summary of what those tools are and what you can get from them, you can go there. So if we go back here, as I mentioned, you can either click on the map if you want to set a location, or you can move the map, zoom in, zoom out. So we'll just pick something here, say west of Yakima, and set this location. And from there, I'll show you real quickly the smoke point forecast guidance. Currently this is in tabular format, and it's really kind of ugly and difficult to read and digest, and so we're going to be changing to a more graphical product, and it'll be more of a time series type thing. So this should be a little easier to look at shortly. But I really want to go down and show you the trajectories and the playground. So here's the smoke trajectories. So you just click this button, open interactive viewer, and run trajectories. And we wait for it to come up. This is the GetBlueSkyorg website that I told you about, that you needed an account, but if you come into it through the WFDSS-AQ page, you will not need an account. You just come in on a guest account. So that's the bonus for coming in through this way. So what we see here are, it's kind of a muddle, but it's 3 trajectories by default, starting at 3,000 meters AGL, 1,500 meters AGL, and 500 meters AGL. And today, it just so happens that the winds are very different at the different elevations. So the upper level winds are more from the northwest, while the winds closer to the ground are more from the west to southwest. And with this tool, this is an ArcGIS interface, so you can do all the usual zoom in, zoom out, pan. And if you want to put a new trajectory in, you just click this Add Trajectory to a Map, and you can change your start hour, you can do backward trajectories or forward trajectories, and you can change the height above the ground from which your trajectory is going to start. Because it's important to remember that trajectories are not dispersion. The trajectories are just telling you, based on the 3-dimensional wind flow, where is that smoke going to be carried. There's no heat from the fire or anything like that. So that's important to keep in mind when you're looking at trajectories. And so if you think that your plume is going to get up to 100 meters or so, or whatever the height of your transport winds are, you can choose that height to start your trajectory. So I don't want to spend too much time on that. The other one I want to show you is the playground. Again, we'll click on this Start Interactive Modeling button. And we can see that our location for the fire has followed us through here. We can change the size of the fire. Say we're just going to burn 1,000 acres today. We can change the start date. We can change the moisture level here. You can set one of these presets, or you can actually go in and change the values if you have a good idea for fuel moistures. This is the website that we're revamping right now. We are going to have the finer resolution meteorology available, but right now all we've got is the 40-kilometer GFS. If you wanted to run through quickly, you could just choose from these drop-down windows which models you wanted to do and then click through to results. But I'll go through the tabs one at a time so you can see some of the differences. Here's our fuel loadings. You have the option of using FCCS fuel loadings or NFDRS or Hardy. We can run them all just so you can see the comparisons. And this bears out what I was showing on some of those earlier slides. For this location, we're not seeing huge differences in the fuel loadings, but you do see that there are some. Also, the better information you put into the model, obviously, the better the results are going to be. So if you have information on your own fuel beds, you can either choose from this drop-down window of FCCS fuel beds, or you can put your own values in if you know what your fuel loadings are. And this is where I was really talking about when I said that just because you can enter variables doesn't necessarily mean the models will use them. Depending on which models you're using, they'll use only some of the fuel moistures and only some of the fuel loadings. So you could change these things and see no difference and wonder what's going on, but that's because the model's just, whichever model you've chosen isn't using it. So and here this just gives you an idea, or this tells you which models you've chosen as you step through the pathway. So we'll click on to consumption here, and uh-oh, why does this always happen when I'm demoing? Okay, we'll try using FEPS. Maybe we'll go back to consume and see if that'll work. So the model is, no, okay. So the model's actually running on the server as I'm clicking through these. And again, each step of the way, if you think you've got better information as far as what's being consumed, you can change those values and use those going forward. Then we'll go through to emissions. We've got FEPS and EPM. We can compare the emissions from those two models as they run, and you can see that EPM is putting out quite a bit more in terms of emissions than FEPS. Plume rise, we're just going to use this plume rise from the Western Regional Air Partnership, and this is basically more of a time rate thing where it's telling you that most of the active burning is happening in the afternoon, and so you're seeing your greatest plume in the afternoon. And then we go to smoke dispersion, and this is going to take probably a minute or so to run, because it's using, this is the only step where you don't have an option of which model to use, and what this is using is the high-split dispersion model. What we were looking at on the other website was the high-split trajectory model. This is using the high-split dispersion model, and as we're sitting here, it's running the model on the servers back in California, and this will take just a minute, but And as I mentioned, we're going to be revamping this page so that rather than stepping through each of these things step by step and having to wait for the results, you can set up your model, set up your consumption and emissions and so on, and go just to that step, and then set up your dispersion scenarios. And depending on how large your fire is, it could take several hours to run, or it could come back in just a couple of minutes. But in this case, we're not doing anything particularly fancy. So we've got our output, and I'm hoping this is going to work over the webinar. It's a simple animation. This is a 24-hour forecast. And as we step through, not much, oh, there we go. Now we're starting, not much in the way of dispersion from this fire on this day, but you can step through it one step at a time to see your output, and then you can click on results and create a report, and this will tell you what the inputs and outputs were at each step of the modeling framework. And then at the very end, what you'll see is a graph of maximum concentrations over the entire 24-hour simulation over that area. So this is, right now, it's not as easy to go back and rerun. You can only do one model run at a time, so you would have to save this report and then go back if you wanted to change your inputs and do another run. This will be easier to do once we have the revamped, updated playground. But this is how you'll be able to get in and start interacting with the models and actually changing your inputs and seeing how that affects the outputs. So I think I'm going to stop there and open it up to questions. The other tools I talked about are pretty self-explanatory, and you can probably play with those on your own. But if you have any questions, just let us know. So I think I will stop there, Josh, and turn it over to questions.
Okay. Well, thanks, Miriam. Maybe if you can put up that slide that had the list of the links to the different tools.
Okay. Let's see. Here we go.
There we go. Okay, yeah, let's leave that one up for a little bit. Do any one of the questions that came to me while we were going through that is there, and I know you can get in there and play around with them, but are there some tutorials out there that'll sort of walk you through the different steps and sort of how to interpret some of the outputs and that sort of thing, or is it kind of a learn by doing type setup?
Right now it's a learn by doing. I have put together a couple of tutorials on each of the one on the trajectories, I think, and one on the playground, and so I could probably upload those or send those to you if you need. I put those together for an RX410 class. So,
okay.
But we are going to be developing more training tools here within the next year.
Okay. Well, that's some very powerful and very interesting tools you showed us there. I really appreciate that. So I'll go ahead and start getting to the questions. They're starting to come in. We've got quite a few. So if you have any, go ahead and send them, and we'll try to get to them all. But they're starting to line up. Okay. So Tom Moore, the first question from Tom Moore says, the modeling results for the Springerville area are not pixels, right? They are 4-kilometer grid cell results.
Actually, those were, for the model results for Springerville, that was actually the observation was from a PM 2.5 monitor. The model output was actually a 12-kilometer resolution model.
Okay. Okay. All right. Let's see. This is from Lee Tarnay. I think the most important thing for us in Yosemite would be to get the polygons from the FS Pro runs as input for the emissions models. Are we going to be able to get there for this coming season? Right now I have to do all the emissions estimates for daily growth and forecasted growth manually, and it takes way too much time.
Yeah, right now we don't have that capability. My understanding of FS Pro is that that's more of a probability, and Farsight is actually going to give you the actual acres, and that's what we were doing in the Southwest. We were taking the output from the Farsight runs, or the near-term fire behavior, as they were calling them, runs, and using that to inform our emissions and dispersion model, but we were doing that manually. And so that's one of our primary goals for this year, is to try and get that to be an automated process. But right now, unfortunately, no, you're going to have to do that manually.
Okay. Doug Mitke asked, does the custom trajectory option take complex terrain into account?
Yes, it does, to the extent that the model knows about the terrain, the trajectory model knows about the terrain, so it's giving you, I don't know if this is what you're asking, but it's giving you the height above the ground. So if the terrain is rising and the trajectory is staying level, say with respect to sea level, the trajectory is going to be closer to the ground. But I think also what you're asking is, for example, are you going to get downslope flow or something like that? And you certainly could, because it's just really, this depends on the meteorological model and how it's handling the winds. And the trajectories are just following the three-dimensional winds. So if the trajectory is close to the ground, then it should be impacted by the terrain.
Okay. Trent Wickman asks, I heard that a wizard was going to be developed for the playground so that a user could screen for the historical meteorological info for a particular location by season /mixing height / wind direction, etc., and then use that screen meteorological data set in the dispersion modeling step. Is that still true?
If I understand your question, the answer is yes. One of the things that we're changing with the playground is allowing the user to use a simplified meteorology, so that it will be something like V-smoke, where you're just using a constant wind speed and direction rather than using the 3D meteorology from a meteorological model. So if that's the question, then the answer is yes. And if it's not the question, contact me later and we'll try and sort it out.
Okay. Or Trent, you can type in again and I'll try to, if that didn't answer your question, we'll try to get to it. Michelle Fiddler asks, where can we find real-time smoke data versus planning models?
NOAA has some kind of real-time. There's the HMS hazard mapping system that provides smoke plumes, and that's from satellite. It's hand-drawn, but it's from satellite output, and usually that's a couple hours behind. There's also, let's see, what am I thinking of now? Let me look at your question again. The other thing that I look at is just visible satellite imagery, 1 kilometer visible satellite imagery to show me where smoke is now. But that is all I know about right now.
Okay. Rob Beery asks, is anything being done to model nighttime diurnal smoke or settling smoke close-in resolution 4 to 5 kilometers? This seems to be our problem period with smoke across highways and into towns.
Yeah, this gets to a much finer resolution. Gary Achtemeyer in the the Southern Research Station of the Forest Service has done a lot of work on this, and he's got his PB Piedmont models, for example, and they're much finer resolution. The problem is that they're pretty complicated to run and they take a long time to run. So it's really not practical to do that in real time. What we're trying to do is, with always faster computers, is get down to finer resolutions, and hopefully within the next couple of years we'll be able to do that, but we're very close to getting 2-kilometer model output up and running for California and Nevada. And with the Southwest, for a couple of days when the fires were threatening Los Alamos, we were able to get 3-kilometer model output. And so at those resolutions you're starting to be able to resolve better what's happening on a smaller scale with roads and towns and things like that. But right now, in a real-time sense, to be able to get, look at the model output today and see what's going to happen tonight, we're still a little ways out from being able to do that.
Okay. Trent Wickman has a comment. It says, we need a higher height option for trajectories to get at winds above the mixing height at 4,000 to 5,000 foot AGL, about 4,000.
We need a higher height option. Oh, I see. Above 3,000, yeah. Okay, well, I will note that, and as we redo these tools, we'll make sure that that comment gets included.
Okay. And Shelby Law wants to know if all of these tools were available in 2011?
Pretty much, yes.
Okay. And Nancy Lee Wilson asks, will we be able to enter local weather into the playground area? RAW's NFDRS stations are worst case and not the weather at the burn unit location.
Yes. So for the playground tool, you'll have basically two options. You'll be able to choose a weather model that'll have, the 3D meteorology predicted, or in a simplified sense, you'll just be able to put in, like, if you know that you're going to burn on a day when the wind is from the southwest, because that's the only option you have, then you could just do a simplified run using, a single wind speed and direction. But those will be your two options.
Okay. Gordon Anderson has two questions. How about adding state air quality staff, not natural resources staff? And then, can WFDS air quality be used for Canada fires, or how far into Canada can one locate fires?
Okay. For the Canada question, we don't really have it linked up to run in Canada, in the sense that we are not pulling in the meteorological models up there. We can get, as far as fire locations, we can get obviously the satellite detects, but we don't have input, or we don't have access to the Canadian version of the ICS 209s. So there are some, I know that University of British Columbia has a Blue Sky version running. I don't know exactly what area they cover. So I would say if you want to get in touch with me later, I can try and find out that information for you. And then I'm not sure I understand the question about adding state AQ staff and not natural resources staff. So maybe if you can,
I wonder if that's
clarify that.
That might be in reference to my poll that I put out. There's been a few.
Oh, I see. Okay.
There's been people that have made some suggestions on how to improve those, and then those are appreciated. I'll try to make those a little more responsive to the audience next time.
Okay.
Yes, I think that was more for me. Kelly Van Druten has a question, and that's what and where does this information get transferred or plugged into WFDS? Is it simply taking screenshots to include in a decision?
Good question. So we were just meeting about that last week. Right now, not much of this information is getting put back into WFDS, but within the next 3 to 6 months, we're really going to work on getting this information so that, and actually using some of the stuff that's already in WFDS, like the zimograms, for example. There'll be an air quality or a smoke risk assessment diagram, basically, is what it's called. And so these data and these model outputs are going to be better integrated into WFDS within the next probably 6 months or so. But right now it's minimal.
Okay. Julia Rutherford asks, hi Miriam, are the smoke products for the Wallow archived and available anywhere?
Yes, Julia, they are, and we've got them on our servers here, so I can help you with that anytime.
Okay, Holly Kleindienst, and I'm sorry if I screwed that up, Holly, asks if they're going to be handout, or if you're going to provide a handout with these links. Probably a more general question would be, are there sort of published documents walking people, sort of along that tutorial question? Is there some guides to some of these tools out there, some written?
Yeah, not right now. There's not. As I said, we've got a contractor right now that's working on helping us to develop some training materials and so on. So we hope to be having that coming online shortly.
Okay. Steve Pice he asks, your examples were for the western U.S. Is this also pertinent to the eastern half of the country?
Yes, it is. We do have the models running over the entire U.S., and we've also been doing some field work in eastern North Carolina. We had the Blue Sky model, the Blue Sky framework running for the Paynes Bay fire, and we also have several portable PM 2.5 monitors out on the Paynes Bay. We have been evaluating the modeling framework out there, and we do have the output available that's available on some of those links that I showed you. So yes, and obviously some of the issues in the east are different than the west, and you've got much more of the deep organics and that sort of thing, and so there's other concerns, but these models do still apply out there, and they work reasonably well.
Okay. How soon are you expecting the system to be able to handle more complex terrain, like in the Central Appalachians for smoke trajectory?
Really, it depends on which meteorological model you're using. So it should be able to do that now. But the trick is, with the trajectories, trying to figure out what's the appropriate height at which to start the trajectory. And so you may need to do a little playing with that. And also, one of the links that I provided on that last page was a link to NOAA's high split model. So you can do trajectories, and there's different options that you can select from their page that's not necessarily available from the WFDS AQ page. So you might want to play with that a little bit too and try some different options.
Okay. This is a question from John Bonk. On the smoke guidance forecast, are there any plans to use options beyond a default GFS forecast such as NWS, NDFD grids, or NAM12 or WRF? GFS tends to poorly resolve and underestimate true surface pressure gradients and resultant winds.
The short answer is yes. We are planning on looking at using some of those others. We did have the NAM on there before, the NAM12, and took it down. I think we just wanted to be able, for planning purposes, to get out to that 7-day time frame. But clearly, you know, when you get into these issues, and especially areas of complex terrain, obviously that course GFS isn't going to do as well. So yes, we do have some plans to add the output from those other models.
Okay. Pat McElvey asks, says, my main concern here in our part of Montana is pile burning and prediction of best air quality days to comply with some fairly strict air quality rules. How can these tools be used for pile burning projects? How are these tools recognized by other jurisdictions, i.e. the Montana Department of Environmental Quality? And are they open for that agency to use as well?
Yes, the tools are open for anybody to access through, if you go in through that WFDSS-Air page that I showed you. With our redesign of the Blue Sky Playground, we are going to explicitly include pile burning so that you'll be able to do things like change the number of piles or the geometry of your pile or something like that. So keep looking, and hopefully, like I said, by about the March or April time frame, we should be bringing that online.
Okay. Let's skip down a little bit. Steve Garza, just we're running along here. Steve Garza asks, were the results realistic, useful, or accurate for the near-term fire behavior modeling for inputs to smoke models and resulting outputs for the wildfire?
Good question. We found that the near-term fire behavior models were giving us really high estimates of fire growth. How realistic they were, I'm not sure. I think they were a little bit too much on the high side, because on some days we were seeing like a doubling and a tripling of fire growth over the next 2 to 3 days. And in some sense we did want to get a sort of a worst case scenario to understand what the sort of the upper boundary on we could expect on smoke, but just from this one particular experience that we had, it seemed like those NTFB runs were giving really high fire growth.
Okay. Kent Prochaska has a couple questions. Is it possible to get a cross-section through the plume to highlight where smoke will be concentrated at higher altitude versus concentrated near the ground? And does Playground have the capability to use the meteorologist's forecast mixing heights and transport winds from the NDFD grid?
So the answer to your first question is no. Right now we don't have a visualization tool to give you a cross-section. The reason being that we've kind of been concentrating on surface, next to the ground smoke impacts, because that's where people are breathing it. So you could kind of take a look at the trajectories to get an estimate, but that obviously isn't going to give you concentrations. That's just telling you where the smoke is, not how much. And Playground does not have the capability really to use the forecast mixing heights from a forecaster or the NDFD grid, because well, first of all, the Playground is using the three-dimensional meteorological model output, so that should give information on mixing heights, but it's not going to be interpreted by a forecaster. And the NDFD, I believe, is just the two-dimensional. It's surface variables and doesn't give us any information on the upper level, and we need the 3D meteorology in order to run the framework. So we're not using the NDFD right now.
Okay. Ann Hobbs asks, in relation to nighttime smoke, will there be additional work in this area as this is a point in which the PM 2.5 exceedances can happen?
Yes. Again, I mentioned the work that Gary Achtemeyer is doing, and we're hoping to be able to incorporate some of that in what we're doing. Also, again, just as we get our meteorological models improving and at a higher resolution, we should be able to get a better handle on the boundary layer and what's happening within the boundary layer during those quiescent periods, like at night.
Okay. And Kent Prochaska has one more question. Is it possible to add the time of ignition to the Playground /fire information /prescribed burn?
Yes, with our revamping of that site, that is going to be more of an option to be able to set the timing of the burns and whatnot. But right now it's not. I'd have to go back and look, but I don't think right now you're able to set the time of the burn.
Okay. And then one last question, and that's another training question. It's from Claudia Standish, and she just wants to know, hey Miriam, how about a train the trainer?
Yeah, we'll be doing some more of that as we go forward, so yes.
Okay. Well, Miriam, I want to thank you again and really appreciate it. This was some really interesting stuff, and I think that we're going to get some really good feedback on how useful people found this and some really interesting tools you're working on there. So I appreciate it.
Great. Well, thanks for the opportunity.
Sure. And if once again, if you want to get a recording of the webinar and pass it on to someone, or if you missed part of it, I'll have it posted probably in 30-45 minutes. Advances in Fire Practice. The link's on the website. If you can't type all that in, just Google it and it'll pop up. Okay. Well, thanks everyone for coming, and check back with us on the upcoming schedule. All right. Thanks.
Thanks.